right, everybody, welcome back. This is Unit 6, Lesson 3, and we're going to be focusing on covalent bonds. Remember, like co-presidents or co-workers, you share the work responsibilities. This kind of bonding occurs when nonmetals share valence electrons. So they come close enough, as you can see here from this diagram, so that their valence shells overlap. And so the blue electron here becomes part of the black element's outer shell, and the black electron here becomes part of the blue element's outer shell. So they become close enough so their outer shells overlap and they can complete their octet, okay? So unlike ionic bonding, where you get a complete transfer, the electron leaves one element and goes to the next, covalent bonding occurs when two or more elements share electrons in order to get 8 in their outer shell. If you have covalent bonds, we call you a molecule. And so you have covalent bonds when you have a nonmetal to nonmetal, and you also have covalent bonds, as we talked about in class today, within a polyatomic ion. So for example, if you have the sulfate ion, this is a nonmetal and this is a nonmetal. So inside that polyatomic, you have covalent bonds. Now, if that polyatomic attaches to a metal like barium, for example, what do you do with the dead chemist? You bury them. All right, so if they bond together, right, +2 and -2, then that, because these are oppositely charged particles, that makes an ionic bond. So just the polyatomic covalent, and then when that polyatomic attaches to something, you have both ionic and covalent bonds. When we make a covalent bond, the thing that is made is called a molecule. So anytime you have a molecule, it means it has covalent bonds. We also sometimes call it a molecular substance. It's the same thing. It means bonded by sharing. Bonded with covalent bonds. Okay. There's different numbers of pairs of electrons that can be shared. Okay? If you're sharing a pair of electrons, we call those bonding pairs. And bonding pairs are always written in between the symbols. So for example, here in F2, notice that there is one pair of electrons being shared. And if one pair of electrons are being shared, we call the bond a single bond. If you look between carbon and oxygen here, again, we're only looking at one bond, okay? So we're not looking at this molecule. We're looking here between the carbon and oxygen. Notice that there are 2 pairs being shared. And if 2 pairs are being shared, we call it a double bond, okay? Carbon dioxide, then, as the whole molecule, has 2 double bonds. It has 1 double bond here and 1 double bond here for a total of 2. And sometimes you'll notice we can write the bonds as lines. A line is a pair. So you'd have 1 pair here, 2 pair here. That's a double bond. Okay? A line equals a pair. And then you may also share 3 pairs of electrons. See the nitrogens right here? They're sharing 1, 2, 3 pairs. So we would call that not a single bond, not a double bond. Can you guess? That's right. We call it a triple bond. Yay! A triple bond. Okay? If you notice in these pictures, there are some electrons that are not between the symbols. There are some electrons that are not being shared, like over here and over here. Those are not called bonding pairs. Those are known as lone pairs. And so our next job is to learn how to draw these. Before we learn how to draw them, though, let's talk about some of the properties of covalent compounds. So we're going to skip ahead in the notes a little bit. And then I'll come back and show you how to draw them. Skip over this. Let's jump to section 8 and let's talk about some of the properties of covalent compounds. Okay? Again, all covalent compounds are known as molecules or molecular substances. And just like with ionically bonded things, things with covalent bonds or things with metallic bonds have specific properties. And again, if you're walking down the street and you find a white powder and you want to know what it is, you can identify what kind of bonds it has based on its properties. Did you need? Okay. First of all, melting point. They have extremely, extremely low melting points. Covalent things, the most common covalent thing is water. Okay? As you know, right now at room temperature, water has already melted. Its melting point, water is high for covalent things, but it's about 0 degrees. If you remember salt, the ionic compound, it melted at 800. So relatively speaking, compared to ionic compounds and compared to metals, these have very low melting points. They also have very low boiling points. Some covalent things have already boiled, like carbon dioxide that you're exhaling right now, or oxygen that you're inhaling. Those are already gases at this temperature. Okay, they have very low boiling points. Covalent things never conduct in any phase because they're not made of charged particles or mobile electrons. When you dissolve a covalent thing, you don't make any charged particles, so you dissociate a covalent thing into individual molecules, not ions. And finally, covalent things are not malleable. The only thing that's malleable is a metal. A metal by itself, okay? So covalent things are not malleable and they're not ductile. Okay, so that's going to be it for tonight's video. Tomorrow in class, if we have class, we'll be talking about how we draw dot diagrams for covalent things. Have a great night, everybody. Don't forget to put your spoon in the freezer. Bye-bye.
Is this video for us?